Flashback.
This is the setup of Rutherford's gold foil experiment. The part we see in red is a lead block. The lead block is used to cover the alpha-emitting material from releasing radiation to outside environment. The lead block also helps the alpha emitter to target the beam particles to one spot. Alpha particles cannot be observed, so we need something that can detect alpha particles. So we use a screen around the setup. This screen is made of zinc sulfide, hence this is known as a zinc sulfide screen. The part in purple is the gold foil. So, as Rutherford planned, the experiment started, and the alpha emitter started to emit alpha particles.
A little longer than a few minutes later.
The alpha emitter emits radiation in straight lines due to the blockage from the lead block. Here, the rays are straightly sent to the gold foil. Pause the video for a moment and think what happens next. Well, if your guesses are correct, most parts or most rays come through the gold foil. And when they touch the zinc sulfide screen, an illumination occurs and you can detect the presence of alpha particles. Does all particles flow through the gold foil? No. Some particles get deflected, they do not travel in straight lines. For example, if you project 8,000 particles, out of them, only one particle will be deflected from the path. And also, there is another type of motion here. Some particles can stop right at this place and they can bounce back. And this is somewhere like 1 in 10,000. So, what does this experiment prove? To understand that, there are 3 simple explanations. And for explanation number 1. If you consider an alpha particle, the alpha particle has a positive charge. And also an alpha particle has a mass. For an alpha particle which is traveling in a straight line to deflect, there should be a certain obstacle. That obstacle can be a positively charged particle. Explanation number 2. As I said before, deflection of an alpha particle and also reflection of an alpha particle are rare phenomena. These two things also happened in Rutherford's experiment, so it is able to prove that mass and positive charge have gathered in very discrete points called as the nucleus.
$80,000 impressions later.
Would you please stop imitating me? It is starting to get very annoying.
We should magnify the gold foil a bit. If you magnify this gold foil, most of the spaces in this gold foil are empty. These empty spaces allowed alpha particles to travel through them. But in some places there are mass and positive charge, which made them deflect or reflect back. So it's clearly able to understand that most of the area of the gold foil is empty, and in very tiny points mass and positive charge have gathered. Therefore, most of the area of the atom should be empty, and in very small point the nucleus is present. With respect to deflections or scattering angles of alpha particles, Rutherford calculated the typical atomic and nuclear radius. The typical atomic radius would be and the typical nuclear radius would be